Hey, today we're going to talk about data types. Let's start up processing. And let's write the basic program outline. So you have void setup and then void draw with curly brackets. Okay, so when you write a program, often you'll have to use data. You have to store data, you have to manipulate data. Like, think of a program that keeps track of your age. A piece of data, for example, is your age. Your age is a number, and every year that number goes up by 1. So a program that keeps track of your age needs to add 1 to that data value every year. Um, so that's an example of a piece of data in a program. Um, in a computer program, in order to use the piece of data, you have to first create that piece of data. And we already talked about this. You create a piece of data by using a declaration, and you've probably seen it before. Here's here I'm declaring a variable x, which is of type integer, and it has an initial value 90. This component right here, the integer, is the type. This is the variable name, and this is the variable value that gets assigned by using the assignment operator equal to assign the variable x with the value 90. So this is how programmers tell the computers that a piece of data exists through the declarations. And when you declare a variable, that is, when you create a variable, declare and create are they mean almost the same thing. When you declare something, you make something known. That's the definition of declaration. Well, in computer programming, when you declare a variable, you're making the variable known to the computer. Saying that it exists and it has these particular properties. So one thing about the declaration is the type, and that's the first thing you specify when you make a declaration, the type. Here, x is of type int, which is which is an abbreviation for integer. And integers are values that include, or are numbers that include the negative whole numbers, so negative infinity all the way to negative infinity all the way to negative 3, negative 2, negative 1, 0, 1, 2, 3. The only exception in computer programming is that instead of going up to negative and positive infinity, the computer will actually at some point can't represent more whole numbers, and that turns out to be around 2 billion or something. 2 billion. If you want me to be more precise, it's not exactly 2 billion, it's actually 2 to the 32nd, positive 31st, minus 1, which is, let me do that out really quick. I'll go to Google. 2 to the 31st, minus 1. That's, let's see, there's, I'm sorry, 2,147,000. So it goes up to that number. So you can't have values that are beyond that number. And there's also a limit to the highest negative value that you can have, and it's 2 to the 2 to the 31st. So it's that value 2 to the 31st, and then take the negative of it. So that integer type can only take in numbers between negative to the 31st. So negative, we'll call this, that's million, billion. So it goes from negative 2 billion to to positive 2 billion, including 0. So that's the integer. For decimal points, programmers use what's called use a type. It's called double or float. The float type, and like the integer, the declaration for a variable of type float is very similar to a declaration of type int. The form is the same. When I say the form, I mean like the order in which the elements appear. So the type here, you have the variable name, you have an equal sign, which is an assignment operator, and then you have a value. Floats, this stores a decimal point number. I'm not sure why it's called float. It's, a reasonable name would have been like decimal or something, like decimal y. But for whatever reason, programmers chose to call it float. There's probably a reason for it, but I don't know of it. But the decimal point number, it's difficult to talk about the range of the numbers, but because it's represented in binary in a very special way, and I'll have to do a separate video to explain how in binary it's represented. The integers are represented very simply. The float and this other data type, the double, that I'm going to show you, is represented in a unique way, and you don't really need to know about how it's represented, but you just need to know the difference between the float and the double and why they're used and when they're used. The double, it also represents a decimal point number, and I put a question mark for the range here because I don't actually know the range, but what I do know is that the float has a higher precision than the double. What that means is that you're allowed to represent numbers more accurate. You're allowed to do math more accurately with a float than a double. So a float is only precise up to, I think, I don't know, maybe about 7 or 10, between 7 and 10 places after the decimal point. So if you do math, so the weird thing about computer arithmetic is that it doesn't work like the arithmetic that you do in math class. After a certain number of decimal places, the computer will round because it no longer understands. It will no longer understand the number, and that's a little bit tricky. Like, for instance, if you were to take the sum of the number 6 on line 6 and line 7, the computer, instead of seeing this the number on line 6 as separate, as being different, or I'm sorry, the computer will see the sum of these two numbers differently than we do. We can compute this, and that's just 6.00001 here, and then two nines here. But what a computer is going to see is it's going to try to add this number and this number, and that's because after because the computer's not this precise, it doesn't understand this number, and so it'll just truncate, or it'll just throw away the values after that decimal place. So to the computer, this number is equivalent to this number, And so when it does addition, it's going to come up with this as an answer. And that's very different from what we understand, which is this. Okay, and so you shouldn't try to assign a float point number outside of that range, but you rarely need to be this accurate where you need to change this value down here or change this value down here. But it's something to keep in mind. Both the float type and the double type represent, or they can take on decimal point numbers. But the nice thing about double is that it's more precise. So where the float type might be precise up to in this case it's the 4, 8, 9th, the 9th place. A double. I don't know how more exact. I don't know exactly how more precise it is, but it is at least twice as precise as a float, so that it's more precise in terms of the decimal point, the lowest, the highest decimal point that it can represent. So a float can't distinguish between that number or this number because it's outside of the range of the precision of a float, because it has 10. So because it has 10 places after the decimal point here. But a double can understand this number because it's still within the precision that is allowed. So that's assuming that float is precise up to 100 or 7 or 9 decimal places. And here I'm assuming that the double is precise up to 18 decimal places. And this is a 10 place after the decimal number. So here, I don't know exactly how precise the float is. Here I'm just assuming that it's accurate up to 9 decimal places, which it should be. It should be accurate to between 7 and 10, or maybe more than 10. But that's what I mean by precision. If you have a number that's higher in precision than the type allows, then that number can't be distinguished between consecutive values. So like this number and the number 000 here will be indistinguishable to the computer. But if the type is declared as a double, that number will be distinguished when it's doing arithmetic. You don't have to worry too much about that just for now. Generally, it's safe to use float to represent decimal data, but if your decimal value has a long chain of numbers, consider using the double. The next type we're going to talk about is characters, and I should change this to STUV. And characters are symbols. Now it's you can think of characters as possessing a symbol, and the reason why I say symbol is because there's a character set, an alphabet of a sort, to represent all the possible values that a character can take. So just as the integer can take values between -2 billion and +2 billion, the character type can take symbols, different symbols, and the symbols that it can take are given in the ASCII table. And you could just Google search ASCII table, and um, you'll see different types of ASCII table. But usually the first link is the link that contains all the ASCII values. So here you can see, a list of ASCII values. And I know it's a little bit confusing, but this column is only bigger because there's more. The description of the character is a little bit longer, but you essentially have 4 columns that have the same columns within those columns. You have the decimal column, hex, octal, character, decimal, hex, octal, character. Don't worry about that HTML stuff. The decimal 0 in a character corresponds to the null character. And these are the different symbols. All the symbols that you can represent using a character type is written read on this table. So to assign a value, to give a value to a character, you have to encase it in single quotation inside a pair of single quotation marks. Like this. So I've written my single quotation mark and say if I wanted to store the character, the dot, or let's try something else. So let's say the tilde. That's decimal 126, and it's the key that's next to the number 1. You have to hold shift. That's called a tilde. This is a perfect assignment. You're giving the tilde symbol to this variable called v, and that's okay. You can also have a character w, and it could store anything else. So pick another red character, e. Right? So then, these are 2 examples of a character declaration. We have variables v and w. V takes on the character tilde. W takes on the character capital E. I say capital E just because there are 2 E's in the ASCII table. This capital E here and this lowercase e here, and so they're different. Capital E is associated with the number 69. Lowercase e is associated with capital to number 101, and that becomes important sometimes. And you'll see later on as you encounter some bugs, some errors. Okay, but for now we'll just keep variable v here. Let's see. Let's next talk about colors. So color isn't actually a type. These are all of the basic types inside of a. Actually, I want to cover strings as well, and I'll explain that in a second. But color is a type in the language called processing. So processing is a nice language that gives programmers the availability to draw stuff and to color stuff. So with the type color, you can define different color values. I think it's called, maybe not. I actually don't know much about color, but yeah, that's just good. It's a good exercise to look things up. This is a good chance to look things up. So because I don't know what the color type is, I go to google.com. I search processing, and there's a page on the processing website that explains the different data types, and it's under reference. It's under that link, but I'm just going to start off on the main page. I don't think processing is working for me right now. Yeah, we'll wait for that to load. Nope. I think there's something wrong with the processing server. Anyways, let's move on to string. But basically, the color type is it allows you to assign a variable to a color, so that W for instance, might represent red, or something. I don't know how to write out the declaration, but that's what the processing page, reference page, should allow you to do. So from the processing main page, you click on reference, and you have to search in here for data, and under data, you have a list of different data types. Some we've already talked about: int, float, double. Um, we haven't talked about boolean. Yeah, we'll talk about boolean. So I should talk about boolean. And I already have it up here. I forgot to bring that up. But if you click on a data type, it will give you an explanation. So for instance, let's do color. Since I don't know what color is, I'll give it a second to load here. But let's move on to string. So a string type is a type that allows you to store multiple characters. So sometimes it might be useful to so another note about the character: you can't assign multiple characters to a single variable. So for instance, you can't put in single quotes 2 characters or 3 characters, or any number of symbols. That's illegal. It doesn't make sense to the computer because ASCII characters only come in one at a time. You never see an exclamation mark and then like a quotation mark or like 2 characters. It's one symbol, exactly one symbol. That's what a character variable stores, exactly one symbol. This is invalid because there's 7 characters. A string, if you want a variable to store multiple characters, like up here, character equals ABC. This is illegal. Your program won't run if you type this. But if you use the string type, what you can do is write this. And you can sort of see here that the string W, it consists of 3 different symbols, 3 different characters: the A character, the B character, the C character. And that's why we use a different data type for we'll call this a string. The string consists of multiple characters, multiple value symbols of the character type. So you can think of a character as a building block, and a string is a building that you build with those building blocks. The string W consists of the characters A, B, C. You can also have a string that represents symbols with characters. So WX, and you can have weird symbols, DEF, and then $sign. It can contain any number of characters, of symbols that you want, and you can store sentences, strings. Hello. Yeah, I'll call the variable hello, and we'll say, hi there, friends. So this string, the string hello, we'll call this greeting string. The greeting string variable has the H character, the I character, the space character, etc., etc., and then the exclamation point character. Okay, so strings contain characters. That's all. It contains multiple characters. Characters contain only one symbol. That's it. Then you have a data type called a boolean, and a boolean is special in that it's a type that takes on 2 values, either true or a false value. You can type that. I can't explain to you what true means. I can't explain to you what false means, but you can internally in the computer, the computer understands true to be equal to 1 and false to be equal to 0. And so if you type if you use this as a declaration, boolean y equals false, this means the same as typing boolean y equals 0. This would also work, and I'll show you that later. Um, let's create another variable called y2, and we'll assign it the value true. Boolean y equals 1. This means the same as assigning boolean y equals 1. And that's all the boolean can take. It can take either true or false and nothing else. You can't assign it a character, you can't assign it a decimal point, a number, you can't assign it a negative number or a positive number, you can't assign it 0. Or actually, you can assign it 0. You can only, yeah, you can assign it an integer. You can only assign it the integer 1 or the integer 0. Or the words true or false. That's it. That's all there is to data types. I'm gonna at this point, yeah, for some reason, the processing web page isn't being responsive, so I can't show you what happens when you click one of these links. But the reference page is very useful. It'll tell you a lot about the data types and all the different other keywords in the processing language. But for now, let's print out some variables. Here from lines 2 to lines 10, we've declared a whole bunch of different variables. We've declared 9 variables. Let's print them out, and I'll show you what gets printed out here. So So here I expect the variable. Not So I've already talked about what print does. Prints out to the console. When you print s, it prints out the value of s, which is 90. Right. When you print out t, it prints out the value 3.14. When you print out u, it prints out 6.28, whatever. Now, see, the double is very precise, and if you don't specify that it's, that you want double u, the variable u to store only 6.88, whatever, it's gonna put garbage values after the highest precision that you've specified. So if I explicitly tell I'm not sure what's going on here. Maybe it's not accurate. I don't understand how double works, it seems like, in processing. But in other programming languages, double will actually be this precise when you start it. So if you print it out with the print statement, you will actually get 6.220000. Here, processing understands floats a little bit differently, but what's important is that it's accurate up to what you've specified. So before I had 6.828, the double does store 6.28, but if I specified 425, it will, and it should print out forgot a semicolon there. It should print out 6.28425. And you can see here 6.2842 and 49. That's very close to 25. There's that rounding error. So the thing about decimal points in a computer is that there's always a rounding error associated with it. So you'll get your number, but not precisely that number. You'll be off by a tiny bit, less than the value of the variable itself. Okay, and then that's the double, and let's print out the character that's stored in V. That's the tilde right here. Let's print out. You'll see here if I put like 2 symbols, it won't run because it's wrong. It's not the right. It's not a correct value. Let's print out the string W, which contains ABC. Right here. Here, ABC. And let's print out X. W plus X. Okay. You can see here that W gets printed first. That's ABC. And then this plus operator, what it does is it puts the value of W and the value of X side by side. So the value of W is the string ABC, the string of characters ABC. The value of X is a string of characters pound $DEF $. or hashtag def $. And so that plus symbol puts the two strings side by side like that. Now if you want a space in between it, you can put a space character, and then you can nest that space character in between the two plus symbols. I'll put some spaces here so that it's easier to read. So now print is going to print out the string W, a space, and then the string X. And you'll see that the string W is here. You have that space, which corresponds to this character, the blank space. So in the ASCII table, there's actually a character for the space, and that's right here. It's labeled space, but it's actually empty. Yeah. Let's print out a greeting string. Here, this allows you to print a sentence. Hi friends. Hi there friends. There you go. And then here, if I print out the boolean value y, I think what gets printed is actually the number 0. Oh, no. In other programming languages, when you print out a boolean value, you'll print out 0 or 1, not like the entire word false. But I guess in processing, it does so. Oops. Y2. True. Okay, great. So that's how you declare variables, and this is an example of a use of variables. Here I used the print function to print all these variables. You can do math with those variables. You can put two variables next to each other. You can do a bunch of things with data, and that's why it's important to tell the computer what the data is. We'll stop there.